Okay, so it's 6:18. This is video 135, and I'm doing the 4 problems that I gave you yesterday. And on the first two, since I've done them so many times, I just figured I'd put out the answers and then make some comments one more time before we move on tomorrow. Notice in number 1 that everybody's co-prime. You always look for that before you start factoring. Notice that the first term is negative, and I explained to you that's going to be very important. The negatives and the positives really count in this math. So in this particular case, I factored out the -1 as I taught you to do. Basically put it there and factored the rest of the expression. So you'll be expected to do that. I want you to be able to factor something like that. So I put the answer there, and I didn't spend a lot of time doing it. And so there it is, first term negative, and we considering the factorization negative as well. And I mentioned to you that an upside down parabola becomes an important idea later. And on the second one, again, the first term is positive. The coefficients are co-prime. I found the key that worked when I did this math. It was a -120 and +7. And I worked it out over here. And again, there you go. The trinomial being factored into 2 binomial factors, okay? All right. So those are the answers there. I'll consider that done unless I hear from other people who want more. There's tons of problems in the books to do. It's up to you. But certainly no need for me to do these. And besides, I'll be doing the same work for 3 and 4, which because I only did it once yesterday, I'll focus on a little bit more now. Okay? So let's take a look at number 3 here. And again, we're taking advantage here to repeat what we did yesterday. The area, 2 dimensions, plane figure, P-L-A-N-E figure on the whiteboard here. And it's a trinomial. The 3, the 20, and the 7 are obviously co-prime numbers. And you're asked to find the perimeter. So it's worth talking just about here what we've been doing. So we started where we knew the perimeter, FOILed it, and found the area. Now we're going back. In fact, a couple times we knew the area and one side, and we divided that one side that we knew into the area and found the missing side. And now we've sort of taken it to the end, and we know the area. And because it's a factorable expression, we can factor it and find out what the perimeter is, or the sides, because 2L plus 2W equals the perimeter. So I'll do that as the problem there, and you'd be expected to do so. It's very traditional, typical work from the Regents. And I'll move the camera over here a little to the right-hand side, and let's see. We get a -21 and a -20. Well, that's an easy one, right? So because -21 plus 1 equals -20, and there's the key. So we'll rewrite this. We'll do it, lift it up just a little. We'll do it over here. And we get 3x squared minus 21x, again in any order, plus -7 is breakdown for this, and again you can check that it's correct. And I factor out the 3, and there's your x, and there's your -7, and then again, most of you hopefully can see that there's the correct factorization. So it's 3x plus 1 times x minus 7. And now, since there are 2 lengths and 2 widths, the Regents would expect you to easily be able to come up with a -14 on this side. Excuse me. excuse me again, negative 12 on this side, and 6 plus 2 is 8x. So there you go. Okay? And that's basically what's going on with number 3. I could fill in the data that I calculated, maybe to show off. And what is this? 3x plus 1, and then x minus 7. And there, of course, is your area. Okay? So you're expected to be able to do that. And it's done for you. You can pause it now. I need a little bit more space here. I'm starting to erase the rest of this. And now we go on to the number 4, which again was not really a new idea, to be fair, that I introduced yesterday. And this is tried and true Regents math that kids have been doing for generations now. And so here, instead of 2 dimensions, as we've said so many times, there are 3 dimensions. And my job here is to factor this. But because this starts with degree 3, as you can see, it goes down to degree 2, and I can put a 1 here. Since I'm taking my time and explaining everything, then I'll go up and factor this, and there'll be 3 separate factors which will represent a length, a width, and a height. Okay? So I'll move up the camera a little bit, go a little bit to the left-hand side, and write this out, and go right to work, anticipating what I have to do. And so here we go. The x factors out. And what number does all of these 3? Let's see, we got a 40, we got a 28, and we got a 24. It looks like the 4 is going to get the job done. Let's see what we have. And we'll check for coprimeness now. Okay? And so I'm just sort of working, much like, by the way, the 12 and the 7 guarantee that I'm coprime. And there's the minus 10. Okay? So that's what you have to do. That's what it's all about. That's the game. That's what they want. Okay? And so there's the first factor. So we call this monomial factoring. This is what's left. And now we have negative 120. Here, I'll write it over here on the side so the thought is clear. Negative 120 and negative 120, and the factor here is 8. But again, you play around with it. That's your job. It would be positive 15 times negative 8 gets the job done. No, 120 has a lot of factors, but come on, this is the Regents math. You don't expect it to be that easy. So this times this is this. There's the 7, and when you play around with it, 15 times 8 is 120, and 15 minus 8 is 7. So now, in any order whatsoever, I'll break this up, and I have 4x times 12x squared plus 15 x minus 8x minus 10. Well worth it slowing up and making sure you didn't make a mistake. This goes to that, and that goes to that. This is the same as that, as we've done so many times. So we're moving on here. And then we have the factor here, which is 3x. And there you go. That's going to be 4x plus 5. And there I go, 4x plus 5. And you see it's all working out very nicely. The negative 2 gets the job done. So the factorization is 4x times 3x minus 2 times 4x plus 5. And you'd be expected to do that in your Regents course. And then in any order, because we don't know what the restrictions are, we just mark these out, okay? And now I'll move this over so you can see what I did. The order isn't important. And then on the right-hand side, I'll add these up because there are 4 lengths and 4 widths and 4 heights. And now I put in my numbers. There's the 4x, there's the 3x minus 2, and there's the 4x plus 5. In any order, unless we knew more. And so that's 16x. Are we okay here so you can read everything? Okay. A little bit up farther. Sorry about that. All right, there we go. 16x plus 0, 12x minus 8, and 16x. And I like these kind of things because these are the things you're supposed to know. These are the things that we taught you, adding them, subtracting. 16 and 16 is 32 plus 12. And if I didn't make a mistake there, it's 44x plus 12 is the length of the edges subject to restrictions. Okay? So I'll get off a assignment on the math that we did this morning. This was the math that you expected to do today. All the answers have been circled for you, and you're perfectly welcome to get back to me if there's something here that you want me to do again. But if I don't hear anything, I'm just going to move on. I don't think the math is all that difficult for smart kids like you. Okay.